And I'd want to say thank you to the organizers of this. Genuinely, what a great way to spend the Sunday morning. And also, thank you. Maybe we could have a round of applause emojis for Natalie Pustanovich, our great MC. Okay, so I'm going to be talking about defer, and it really is my favorite subject. This is me. Natalie's right. There's too many of me everywhere. So I completely understand if you get sick of that. I'll just try and be better at not being on stuff. So I co-founded Pace, which is completely back-end. It's a monolith. So I'm with the previous speaker on that one. And it's completely Go. And so lots of technical things come out of that process, and we blog about that. And as Natalie said, we also do the Go Time podcast. I just want to do a quick shout out because it's a live podcast, and it's this kind of atmosphere, which is great, and it's been so much fun hanging out with everyone. I won't have time for questions, but you can ask me things on Twitter, and I'm happy to answer any questions about Go if I can. We did do a Go Time episode on defer, which I recommend. It's with Dan Scales, who was the engineer that implemented some of the recent optimizations, and I highly do recommend that one. So at Pace, we actually use defer. In fact, I did a search. We've used it 418 times, and we've only been doing it for 6 months. That's an average of 69 defers a month, which is phenomenal, I think. I'm going to, as Natalie said, go through what defer is and how we actually use it to make our code better. I'm going to look at some of the common gotchas to watch out for, and then take a little deep dive on how defer actually works and some of the performance enhancements. And I'll answer this age-old question, should we be using defer? And you don't need to be Nostradamus to figure out where I'm going to land on that one. So what is defer? Well, here it is. You defer a function, and it runs when the surrounding function exits. And that's kind of it. They run in reverse order, which, when you think about it, is really the only thing that makes sense. It wouldn't make much sense to run the other way. And we'll dig into why that is as well. Here's an example. So we've got some code here calling two functions, goodbye and hello. And since I'm calling them in that order, they print out in that order. So if I were to change this to put a defer in, that actually flips the order around. And essentially what's happening is that the goodbye call is being deferred until the end of our function main, at which point it is then executed. And so just broadly speaking, that's it really for defer. The other strange caveat is that they run in reverse order. So if I were to defer 1, 2, 3 like this, and I'm just printing these out, it prints out 3, 2, 1. And it is worth remembering that it is this LIFO thing. But that's worth bearing in mind when you use it, because you can see some strange behavior if you don't remember that. So when should we use defer then? Well, I use it when closing files. So here's quite a good example. You can see we open these two files, F1 and F2, and then we process some text, and then we close the files after. So that makes perfect sense. But of course, some long arrows will tell us there are a couple of places in here where we actually could exit early and leave files unclosed. So if at number 1 we exit there, we can't open file 2, then we've left file 1 open, and that's bad. You shouldn't leave files open. You should tidy up after yourself for lots of good reasons. And that's really where defer comes into play. Otherwise, we'd have to do this. We'd have to keep track of everything we've opened and then remember to close them at every exit point. So it gets a bit tedious. We can instead just write code like this, which is very easy to read. It's the main benefit of defer. Makes code easier to read and maintain, I think. Michael McLaughlin from Cloudflare pointed this out, that this actually encourages ignoring the error return on close. And that is a concern, especially if you're writing files, because the close call finishes up the writing, and that could error, and you care about that error. So check out the sync method for a solution in that case. And there's a few more advanced things you can do with defers as well if you really care about those errors. Another time is when making HTTP requests. you have to close the response body when you make a request. It's quite easy to forget to do that, but it is something we have to do as the caller. And so it's nice to just immediately do it. So we open, we make the request, and then we immediately, as long as there's no errors, we defer the close of that body. We can then go on to use that body, and we know it's going to get closed however our function exits. We use defer when working with locks. Check out this code. I've modeled here some kind of gosh darn kitchen or something. And we don't want our kitchen to get clogged up and confused, or force people making orders to our kitchen to organize themselves or get in line or anything like that. We want them to just be able to make orders concurrently to our kitchen. So that means we have to manage our internal state. And we can do this with a sync mutex from the sync package. And what we do essentially is we lock at the top, and then later we unlock. And this is kind of a similar problem we have before. We may never get down to the unlock. Things could go wrong with this. Someone could make, if it was a vegan restaurant and somebody ordered a steak, that's going to fail one of these tests, and that will then exit. We don't want to lock the whole kitchen down. We want the kitchen to be able to carry on. And so what we do is we put the defer next to the lock. So we lock it and we defer immediately. And that's what allows us to, first of all, remember that we're unlocking this lock, but also guarantee that however we exit, we're going to unlock the lock here. And Jana made a point about it's great if your attention's easily grabbed elsewhere. It's good to be able to think about the unlocking at the time that you're thinking about the locking, if you see what I mean. So it helps with that kind of maintainability. If we did something like this and made our order secret, like you could place a secret order for some reason, I can't imagine why you would ever do that, but in this case, it's not going to increase the active orders counter. So you can put the defer inside a condition like that, and that will then run in that condition. So it won't always run, of course, but if you've deferred it, it gets called, and that becomes important later. You can also use defer to clean things up, and this is especially good in test files. And here's an example. So here at number 1, we've got a cleanup function, which is just a basic function type that's really just here for documentation. And then at 2, I have this helper which returns whatever it's helping with and the cleanup function. And then inside this, what we can do is just create a little function, assign it to a variable, and just return it there. So you get to delete or clean up, or in this case, delete those test files in the same place where you create them. So again, it's putting everything together neatly, which is nice. And then to use it, we just call that function, we get back the cleanup, we just defer the cleanup immediately. So you know that when this test runs, however it exits, if it fails or if it's successful, we're going to clean up after ourselves, which is very important. You can use a similar technique to build other kinds of APIs too for yourself. Like, here's a simple timer. We have, again, our stop function defined there for convenience. And what we do inside this function is we grab the current time, and then in our stop function, we can use that time because it creates a little closed environment. And we're able to know when that stop is called, we know how much time has passed between the two. And so, yes, over here, we can actually just make use of that value. This is actually a middleware, HTTP middleware example, a very simple one, which adds timing to HTTP handlers. And look how nice the API is. You just get the stop function and you defer the call to that, and you know that that's going to work then in that context. It's sometimes when you see this code, people get tempted to optimize it even more and do something like this. So this number 1 is technically correct, but I think it's confusing. So like, it looks as though it's deferring the setup, but actually, if you look, it's the whatever we get back from setup that we're deferring there. So I find that hard to reason about, and so I just prefer the verbose, boring one. Just create the little variable, describe what it is. It's a chance of storytelling and be clear, a chance to be clear in your code, which is pretty vital, I'd say. I have some facts of the day throughout. Here's one. Ken Thompson came up with the idea of defer, probably influenced by some of the things that Plan 9 did. You can check that out there. I got some of these nuggets from Russ Cox, so thank you, Russ. Right, there's some more of these throughout. So the most common gotcha, by the way, if you haven't seen this optical illusion, then please look at it now. It's mind-blowing. Those two squares, A and B, are the same color. Even though B looks light and A looks dark, they're the same color. So that's like a gotcha. And I feel like the software in our brains needs an update or something, but you don't get them. So that's a gotcha, and that's why. So, and also, it's such a cool illusion. But do try it. It's all 5C, 5C, 5C. I'm not making it up, promise. Okay, so you can defer in loops, of course, because you can use defer anywhere, but there's some weirdness to watch out for. So what would this print? What would this code print? Well, we remember that it's reverse order. So since we'd be iterating in order, I would expect this to print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. In fact, you get 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, which is not what you expected, I think. And the reason for that is because this little item variable here is reused as part of the ranging. And since all the deferred functions are running after this has all happened, you're left with the final value of item when you print it, and that's why you always get 10. So the solution is to use little functions to capture the state that you care about. So just take it in as an argument and then use it, and then you can call it, and that solves this problem. You can also do this inline as well. You don't have to do it as a separate little function. You can do it like this, but I feel like, yeah, it's a little bit more advanced, maybe a little bit less obvious, but it's perfectly reasonable. That's number 3. There are a lot more gotchas in defer, and some of them are very specific to certain types, but there's a great series. So check out these by Inak Gumus, who wrote a great series on defers and gotchas. It's awesome. So how does defer actually work? Well, I went, and since Go is open source, I went and had a little poke around, and I found this. This is a defer struct. And yeah, this is part of the Go runtime. So every time you do a defer, this is the type that is then created. And that's how they describe that defer. And an interesting little detail is this one. This link field is a pointer to another defer. And so essentially defers are a linked list. So the one defer points to the next defer in the list, and so on. So just to visualize what that would look like, if we deferred 1, sorry, I keep pointing the finger. If we defer 1 here, that's the first defer that's going to be called, and that's it. If I then defer 2, well, then that becomes the first one, and that link field is pointing to the other one. So defer 3, same thing. We now are going to call 3 first, and the chain goes down that way. So that's why you end up getting defers in a reverse order, as well as it being actually sensible for the design. It's time for another defer fact of the day. Defer was originally called catch. Both were chosen by Ken, apparently. And they also considered undo and on return as alternatives. So same time, another one of those, same time tomorrow. So what about this defer performance problem? Has anyone ever heard that you shouldn't use defer because it doesn't perform well? Well, I want to challenge that. I would have challenged that as far back as Go 1.6 or something. But there has been work done on optimizing Go over time. And the key point, I think, is that in your case, it probably doesn't matter, the performance of defer. There are probably other things that matter more. But maybe it does matter. And if you're talking about low latency systems and things, or code that's being run a lot at big scale, then of course these nanoseconds add up. But you can see that Go 113 got defers down to 35 nanoseconds. It's kind of the cost of just doing the defer. Compare that to 3 nanoseconds, which is just a normal function call. So yeah, it is more expensive to call defer. Again, probably doesn't matter in your case. So to not use defer for that reason, I don't think is great. But don't worry, there's good news coming. So let's see, how could we optimize this? Let's pretend it's our job to try and optimize defer now. One thing we could do, and this is something that I, with David and Anders, played around with once. We built a little tool which undeferred, we called it, undefer. And it basically would take code like this that had defers in it, and it would just do that sort of open coding thing of extrapolating out the calls and putting them in the right place. And for simple cases, that it worked. But of course, for conditionals, that's not going to work. You know, if we've deferred inside an if block, we'd have to keep track of whether that if block condition was met or not. You know what I mean? So we just abandoned it because it got too hard. But the idea is kind of an interesting one. And it is kind of what's happening in some cases. The compiler will do this for you if it can. So what about these conditionals then? Here's an example with a bakery. We have some seeds. We got some dough and some seeds, and there's a bool which lets you decide whether you want seeds or not in your bread. A lot of people are baking bread right now. I feel like this is a good example. If with seeds is true, then it will defer putting the seeds back. It gets the seeds and then it needs to defer putting them back. So what can it do there? If we try and do the just same trick, we're not sure at this point if these seeds need to be put back or not. And so we do have a solution to this in Go 1.4, thanks to the hard work of Dan Scales and the team. And this is really cool, I think. So where a defer is called 0 or 1 times, i.e., you know, it's conditional. This doesn't address loops, this optimization. The compiler will assign a bit for each of the defers in a variable, which I like the name of, called defer bits, I think is appropriate. The defer statement just sets the bit. So if the condition is met, that defer statement is actually switching on a bit and saving all the information it needs in order to do the defer. And then at every entry point, it essentially does what we were doing manually. It open codes the calls and checks those bits to see if the conditions were met and if it should indeed run the code. This happens for you automatically and is, I think, pretty awesome. So back to our example, a more simplified example. If we have this condition, it'll turn into something like this, where we have these defer bits. If with seeds is true, then we're going to set that bit for that one. And then later we can check those bits and call the appropriate function. So it's very, very, very cool way of solving this and optimizing it. And it's nice, of course, that we don't have to know about this, really. We can just write the code. However, it only works for a specific number of defers. And I think it's easy to see how many that is by looking at this very easy to read code. Well, the clue, if we zoom a little, is in this type here. That's right. It's a uint 8, which is an unsigned integer 8. And it's the bits within that are being flipped around. So that means there's 8 bits, which means there are 8 defers that you can use per function. So if you've got up to 8 defers, you'll get to take advantage, you know, with conditions, you'll get to take advantage of this optimization, which is kind of cool. So let's have a look at what the cost of that is then. So in Go 1.13, we got to 35 nanoseconds. But remember, a normal function call is 3 nanoseconds. Let's see how we did. Well, pretty good. If your code fits into this one of these optimizations, we get defers down to about 4 nanoseconds. And that's kind of pretty phenomenal, I think. It certainly removes any argument that we shouldn't be using defers. And also, I think if you do have functions with more than 8 defers going on, it may be a sign that we could restructure that code a little and shrink the number of defers, just take advantage of these. But again, it probably doesn't matter. There are probably more important things to worry about. It's time for another defer fact of the day. Some of the defer design discussion happened back on Google Wave, which now, since it doesn't exist, is lost forever. So, do you think we should use defer? Well, yeah, I think you should. I think we should use defer. In fact, I think you should all go and use defer now. Defers are very fast, and they make code easy to read, and they make it easy to maintain. So what's the harm? Yeah, use defer, especially in Go 1.14, because of these great optimizations by Dan Scales and the team. By the way, that's his real name, Dan Scales. He's a programmer, and his name's Dan Scales. Do you know what I mean? It's like lazy writing of somebody, like, oh, you've got to come up with a character as a programmer. Do you know what I mean? It might as well call him Jonathan Hackerman or DevOps. Thank you very much. I'm a little early, so maybe we do have time for questions.
Let's check if we have questions written. We don't have questions. Good. But maybe you want to tell about this beautiful background.
Was that one on yours?
Yes.
What do you mean, beautiful?
Handsome.
That's a nice
Sorry,
picture.
I meant handsome. Pardon my English.
Oh, no. both wrong. Yeah, did you take that? I look like a plumbus. I look like I've got the body of a plumbus.
Yes, this was right during Gotham Go. Gotham
Go is a great conference, isn't it?
Great.
But you have to go to New York. This one.
It takes time.
It
takes place this time of the year. It's usually around April. Yeah. Still no questions coming through, but I saw a lot of tweets already, so you're doing a great job. Especially kudos to the way you introduced the structure of the talk by the levels. That's really nice. Thank you for that.